The t distribution. Okay, before I tell you what is a t distribution and how it look like, how it came into existence, what are the properties, before I tell you that, I think it's a good idea to review what we are doing and what we have done so far. Let's move to the another page to see what we have done so far. So far, we have created a confidence interval for one population mean, right? When the sigma was known to us. What we were doing actually, we were having a sample mean and plus minus the margin of error. This was our confidence interval, right? We have created this confidence interval, and you remember I have also written this in this way. X bar minus E, now I'm writing the confidence interval, X bar plus E, and this is the confidence interval. But when I created the confidence interval for the one population mean, what was my basic assumption? That I know sigma. Sigma is known. This was my basic assumption when I was doing these things, right? Sigma is known, the population standard deviation known to us, right? But what happened actually in actuality, the sigma is, in most of the cases, the population standard deviation is unknown. Why it is unknown? I will explain you in a minute, right? Why it is usually unknown. The reason is this. Now try to understand this. We are trying to estimate mu, right? Why we are trying to estimate mu? Because the mu is unknown to us. And if the mu is unknown to us, how we can know a population standard deviation? If the population mean is unknown, how we can have an idea of the population standard deviation? Recall from the concept that what is a population standard deviation? Population standard deviation gives you the average distance of all the observation in the population from the mean of the population. That's the average distance. And what is, when you don't know the mean of the population, how could you know the population standard deviation? So far we have done, we have given you an unrealistic situation. What I mean by the unrealistic situation, we are trying to estimate mu, we are trying to find the confidence interval for mu when the sigma is known. This is an unrealistic situation. And now we move to the more realistic situation. And what's that realistic situation? When the population standard deviation sigma is unknown, okay, that's a realistic situation. The population standard deviation is unknown. What we do, we approximate the population standard deviation by a sample standard deviation. That's what we do. We don't know the population standard deviation, but we have the sample data, and we can very easily compute the sample standard deviation, right? And what happened when we approximate sigma by the S? What happened? The sampling distribution, X bar, that no more follow a normal distribution, but it follow a new distribution. And that new distribution is called a student t distribution. That's how the t distribution come into existence. I repeat, this is a very important thing you understand. We don't know sigma. Okay, so what we do, we approximate sigma by a sample standard deviation. And when we approximate sigma by a sample standard deviation, the sampling distribution of the sample mean X bar follows a new distribution, which is called a student t distribution. Look at that. In case of a z distribution, we have X bar minus mu over sigma over the square root of n. Now remember, we don't know this sigma. So what we do, look at that. We approximate this by S, and this is a new resulting variable. And that variable follow a new distribution that is called a student t distribution, which has n minus 1 degrees of freedom. Right? So this is very important that you understand what is the difference, what we have been doing so far. I will explain you how this t distribution look like, what are its properties, what are its shape, how it differ from a normal distribution. In the next slide I will show you, but just bear with me. So standardized version of the sample mean. Suppose that a variable x of a population is normally distributed with a mean mu. Then for a sample or samples of size n, the variable t which is equal to x bar minus mu divided by s over square root of n, has a t distribution. It has a t distribution with n minus 1 degrees of freedom, right? So now what I'm going to do in the next slide, I'm going to show you how the t distribution look like, what are its properties, and then you will better understand what I'm talking about. Let's move. Now we have this picture, this diagram. The dotted curve is a standard normal curve. Look at this dotted curve, a black dotted curve. And we have a three t curves. For every degree of freedom, we have a curve. So t curve is a curves. It's actually a family of curve. It's not a single curve. It's a family of curve. For every 1 degree of freedom, we have a different t curve. So right now I have 4 curves. One is this dotted curve, the black one, the black dotted. This is standard normal curve, and the 3 t curves. Look at this blue one. The blue t curve, the blue one, has 2 degrees of freedom. This the purple, the brownish one, the golden color, whatever you call it as. This has a 5 degrees of freedom, and look at the red t curve, which has a 15 degrees of freedom. Now you note one thing. One thing is very clear. As I'm increasing the degrees of freedom, as the degrees of freedom are increasing, my t curve is becoming more and more to like a normal curve. It's very clear. Look at the blue one, look at the yellow curve, and look at the red curve. As these are all 3 t curves, as I increase the degrees of freedom, as the degrees of freedom increases, my t curve becomes more of a normal curve. I will show you in a minute in Applet. It will also explain the same idea. Okay, so I hope you understand that. Let's move to an Applet now. Okay, before I show you an applet, I thought it's a good idea to discuss the property and then move to the applet. Let's understand the basic property of t distribution of t curve. Number 1, the total area under the t curve is equal to 1. Number 2, the t curve extends indefinitely on both directions, approaching but never touching the horizontal axis. A t curve is symmetric about the point 0. And number 4, as this I already told you, as the number of degrees of freedom becomes larger, as the number of degrees of freedom increases, t curves look increasing like the standard normal curve, right? I will explain all these things. You might be wondering, I'm just reading the slide, but I will explain all these things in the applet, and the description of the applet I will give you in the comment section, and so that you can also access that applet. Let's move to the applet now. Now here is the applet I'm talking about, and look at this one. This is the t distribution. Look at that. It is a t distribution with only 1 degree of freedom, right? Look at that. Now let me explain all these properties which I told you. The total area, this total area is equal to 1. The total area, this green area I'm talking about, the total area, excuse me, the total area, this green one, is always equal to 1, right? This is a t distribution I'm showing you with a 1 degree of freedom. Number 2, this curve is symmetric with respect to the 0. Look at that. This is the 0 point, and this curve is divided into 2 equal parts, and these 2 parts are the mirror images of each other, and this is exactly what the idea of symmetry is. Look at that. This curve, from both directions, this curve gets closer and closer and closer to the horizontal axis, but never touches the horizontal axis. This is the thing which I told you in the previous property. And next was, as we increase the degrees of freedom, the 4th property which I described in the previous slide, that as the degrees of freedom increases, this t curve look like a normal curve, right? So let's see what I'm talking about. And let's see that. So I erased the previous drawing, right? And now I want to show you how this curve look like more a normal curve as we increase the degrees of freedom, right? Note that, look at this slider. As I move this slider on this side, as I increase the degrees of freedom, As I increase the, look at this curve. It's a normal curve. It's a t distribution with 1 degree of freedom, right? So what I'm going to do now, I'm going to move this slider on this right side, and this will increase the degrees of freedom, and you will see the change in the shape of this T curve. Look at that. I am increasing the degrees of freedom, 2 degrees of freedom, 4 degrees of freedom, 6 degrees of freedom, 10 degrees of freedom, 15 degrees of freedom, 24 degrees of freedom, and 36 degrees of freedom, right? As I increase the degrees of freedom, you can see this curve is more becoming like a normal curve. If you're still not happy, let me show you another demonstration how it looked like. Now I show you the normal curve also. Look at this normal curve. Now this purple one is a normal curve, and this black one is a T distribution. Now as I increase the degrees of freedom, you will see the T curve becoming more like a normal curve. Look at that. Look at that. As I increasing the degrees of freedom, the difference between the normal curve and the T curve is becoming smaller and smaller. Look at that. And at about 30 degrees of freedom, or 32, this is more like a normal curve. So this is exactly the same thing which I explained you. As the degrees of freedom increases, the T curve becomes more like a normal curve. Now we learn how to find the confidence interval for the mean when the sigma is unknown, the second case. And I told you, when the sigma is unknown, we cannot use a z distribution. Rather, we have to use a t distribution. So what are the basic steps? There are 4 steps which we have to take. First of all, we have to have a simple random sample. In step one, we check the basic requirement. Number 1, what is the first basic requirement? There should be a simple random sample. Either the sample size is greater than 30 or the population is normally distributed. This is the step 1. Step 2, we decide the confidence level and find a T critical value, which is represented by T alpha by 2, by using a table or a technology. It's up to your sweet will. You like to use a table or you like to use technology, then you can find this one with n minus 1 degrees of freedom. Remember, we have a formula for degrees of freedom. Degrees of freedom is always equal to sample size minus 1. That's a formula you need to remember for the degrees of freedom. It's always 1 less than the sample size, the degrees of freedom. In step number 3, what we do, in the third step, we find the margin of error by using this formula. E is equal to T alpha by 2. This is the T critical value which we already found, and we multiply by the sample standard deviation and we divide by the square root of the sample size, right? Or if you are not happy with all this hand computation, then you can also use Excel formula, which is given by E. The margin of error can be found directly without going into any of this discussion. You can find this by using the formula confidence dot T, the significance level, the sample standard deviation, and the sample size. And finally, you can find the confidence interval by using in the fourth step. You can find the confidence interval given by the sample mean plus minus the margin of error, or you can also write this like this: the sample mean minus the margin of error as a lower endpoint, and the sample mean plus the margin of error as the upper endpoint. So these are the 2 endpoints of that particular confidence interval. So I have described all these steps in creating the confidence interval. You will further understand the working of these steps. I hope you found somewhat similar what we have already done, but you will understand these steps more when I take a real example. So now in my next slide, I will show you a real example that will give you the working of finding the confidence interval for the one population mean when the sigma is unknown. A psychologist develops a test to ensure attitudes about the public transportation. and 27 randomly selected subjects are given the test. The mean score is 76.2 and their standard deviation is 21.4. Construct and interpret a 95% confidence interval for the mean score of all such subjects. Assume that the population is normally distributed, right? So let's see how we are going to tackle this problem. First of all, we have to construct a confidence interval for the one population mean when the sigma is unknown. We don't know sigma. What is sigma? We don't know. Population standard deviation is not known. We are given a standard deviation, but that is a sample standard deviation. If you look at this problem carefully, the mean score is they selected a 27 randomly people and they give a test to them, and the test score, well, the mean test score was this one, and the mean standard deviation for the test was this one. So we don't know sigma, so we cannot use a z distribution. Rather, we will use a t distribution. It's a second situation. So we already learned the method of creating a confidence interval, and I hope you remember it consists of 4 steps. So what is the step number 1? Let's do it step by step. Step 1. In the first step, we check the basic requirement. Let me write the basic requirements. What are the basic requirements? Number 1, I hope you remember, we need to have a random sample. We need to have a random sample. Let me write that and then I will discuss that one by one. And number 2, what was the second one? That either n is greater than or equal to 30 or the population is normally distributed. Population is normally distributed. Right? Now let's look at these conditions and check that whether these conditions are fulfilled, and we check these conditions one by one. First of all, random sample. Look at that. The public transportation and 27 randomly selected. Look at that. So we have a random sample. That's okay. Okay, look at the sample size. It's 27. Oh, 27. But so our sample size is 27, which is less than 30, right? But look at that. The second condition is met here for the first time. Probably I have been giving you this example. Look at that. Assume that the population is normally distributed. Although the sample size is less than 30, but here we have the second condition is met. The population is normally distributed. Either the sample size must be greater than 0 or the population is normally distributed. Any one of the condition is met. I'm happy with that. So the second condition is also met, right? So both the basic requirements are met. So we are happy with the first step. Let's move to the step number 2. Step number 2. What we do in step number 2, we decide the confidence level, right? The confidence level, and we find the T critical value. Let's understand what is the confidence level here. The confidence level here is a 95%, right? Our confidence level is 95%. Let me write 95, clear? 95%. And now our job is to find the T critical value, right? What we need to find? We need to find T alpha by 2. What is alpha? Alpha is the significance level. If we have a 95% confidence level, our alpha is 5%, and alpha by 2 will be 5.5% is 0.025, right? In decimal, I'm saying. So we have to find the T critical value. T critical value is required. We can do this job either by table or by Excel. Let me show you both the methods that how we can find the T critical value. Let's first see how I can find this by using a table. Let's see a table. Let's look at this table. This is called a T distribution table or T table, right? Now in order to understand this table, look at this extreme left column. This column I'm talking about, this column. This contains this contains degrees of freedom. On this extreme left column, we have a degrees of freedom, and on this top row, we have the values of alpha by 2. Remember, our alpha is the significance level, right? And it's a complement of the confidence interval, right? Remember, confidence level plus alpha is always equal to 100%. That's what we have learned in the previous one. So alpha is significance level. These are alpha values. Now, how we can locate this the t value? Look at that. Our sample size is 27, if you remember. And what is the formula for degrees of freedom? DOF, I'm saying it. It's always the sample size minus 1. So this is equal to 27 minus 1. So we have a 26 degrees of freedom, right? So what I'm going to do now, in this column, I'm going to look the 26 degrees of freedom. Look at this. These are the 26 degrees of freedom. Please mark this line just to make yourself comfortable. This is, mark yourself this line. Now, there are two ways you can do that. Another way, at the bottom, look at the bottom. At the bottom, I have the confidence level also mentioned. Look at the confidence level mentioned. I'm trying to look at that. At the bottom of this table, there are also confidence level. Look at this confidence level. Our confidence level is 95%. And for a 95% confidence level, the degrees of freedom are, look at the intersection. Here is the intersection. For the 95% confidence level, the value comes out to be 2.162. This is the value. This is the value, the T critical value for the 26 degrees of freedom, and for a 90. No, sorry, it's wrong. It's wrong. It's here. This value. Sorry for that. Not this value. I was doing it wrong. Not this one. Click this one. The right one is this one. 95 is this line. I don't know why I was taking that line. So this is the value point. So the value comes out to be 2.056. This is our T critical value. This is the T critical value. 2.056. 2.056. I hope you understand that. So recall our T critical value, T star, or I am calling it a T alpha by 2, was equal to 2.056. So this was the step number 2. We are able to find the T critical value, and we are able to find the define the confidence. Now we go to the step number 3. What we do in step number 3, let me write here step 3. What we have in step number 3, we find the margin of error, and in finding the margin of error, we have a formula for that. And what is the formula? The formula is you multiply the T critical value, the T alpha by 2, which you found in the previous step, and you multiply by the sample standard deviation, and you divide by the square root of the sample size. And this is equal to, all these values are known to us, right? We know T of alpha by, we know the T critical value, we know the T star. So let's plug in the values. Is 2.056 multiplied by the sample standard deviation, it's 21.4, divided by the square root of the sample size, which is 27, right? So when you plug in all these values in your calculator and you compute this value, our margin of error comes out to be 8.47. So this value comes out to be 8.47. So this is our margin of error, right? You can also use Microsoft Excel to find the same thing, right? And I told you the formula in the earlier part of this video how you can compute that by using Microsoft Excel. It will alleviate all the difficulties, right? Let me show you how I can find the same margin of error by using Microsoft Excel so that you have another option to do the problem. Let's do that. So let me show you how you can do that. You go to the formulas, you go to the more function, you go to statistical function, and try to locate the confidence.t. This is the confidence.t. Now you plug in alpha, it's 0.05, the significance level, it's 21.4, the sample standard deviation, and sample size is 27. So you plug in all these values, press OK, and you get the margin of error as 8.47. So you can get the margin of error without even finding the critical value. You can directly compute that without any problem. So this is such an easy step. I hope you understand that. Now we are in step 4, and in this step we write the confidence interval, and the confidence interval, the CI is given by, is the sample mean plus minus the margin of error, or even I sometimes write it in a more convenient way, is the sample mean minus the margin of error. This is the lower endpoint, and the sample mean plus the margin of error is the upper endpoint. So what I can do now, I can plug in the values here. What is my sample mean? It's 76.2 minus 8.47 and 76.2 plus 8.47, and you can very easily do the computation, and you will get the confidence interval. So the confidence interval turns out to be 67.73 and 84.67. This is the lower endpoint, and this is the upper endpoint. How we are going to interpret this confidence interval? This is very important that you know how to interpret this. Let's see how we interpret this. We are 95% confident that the mean score of all such subjects lie in this interval, in this particular interval, where the lower endpoint is 67.73 and 84.67. So what is the average? What is the mean score of all such students? I don't know. This is what I don't know. But what I know, that will be in this particular interval, which is the lower endpoint is this one, and the upper endpoint this one, and I am 95% confident about that. This is Excel technology. I use Excel to print this value. Now what I'm going to do, I'm going to show you how you can get the same answer by using another technology called StatCrunch. Let's see how I can do the same problem in StatCrunch. So let's see how you can solve the same problem using a StatCrunch. I already launched a StatCrunch. So you go to stats, you go to not a Z stats this time, but a T stats, right? We're doing the T distribution. So you won't go to the Z stats, rather you will go to T stats. One sample mean, yes, with data or with summary. We don't have a raw data, we have summary. So we'll go to the with summaries. Now he's asking, are you performing the hypothesis test, or we are estimating? These are the two methods of estimation. We are, if you are doing the hypothesis test or you're doing the confidence interval. We are not doing a hypothesis test, rather we're doing confidence interval. Now our confidence level is 95%, so this value is correct. Don't change that value. Now you enter the sample mean. Sample mean is 76.2. Sample standard deviation was 21.4, and the sample size was 27. Just check this box. It's optional. You want a graph? Say yes, I want the graph also, and hit compute. And when you hit compute, this is the lower endpoint, 67.73, and this is the upper endpoint, 67.67. If I round it to the 2 decimal places, I hope you understand that I can round it to 2 decimal places, right? One sample T summary confidence interval, right? Let's go further. You see, where is this graph? This is the confidence interval. This is the lower endpoint, right? This is the upper endpoint, and this is the middle value, right? The mean. So I hope you understand this example. Thanks for watching.